Hello, good morning students. In the last class we were discussing about the electric potential energy of two charges in absence of electric field. Okay, in absence of electric field na find out ಮಾಡಿದ್ವಿ ಅಲ್ವಾ ಅಂದ್ರೆ from charge A and one charge B, AB. Okay, from infinity I need to bring these charges and make this an assembly of charges. Okay, adena assembly of charges again now find out ಮಾಡಬೇಕಾಗುತ್ತೆ. Okay, once we find an assembly of charges, there is no work done in moving the one charge. Okay, and in bringing the second charge, there is work done against the potential of the first charge. Right? So this work done is equals to charge at B into potential at B due to the A. Then we find out the work done is equals to charge into potential. Then totally we find that as U is equals to 1 by 4 pi epsilon naught into Q1 divided by R. That derivation has one specific property, that is in absence of electric field. Adeli absence of electric field. Now we need to derive the same thing, okay, in presence of external field. Okay, potential energy in an external field. Okay, now potential energy in an external field. Okay, andre field iddaga external field, when there is a presence of field, what is going to be the potential annodana find out ಮಾಡಬೇಕು. Potential energy first ಈಗ electric potential energy due to single charge. Okay, electric potential energy due to single charge. Single charge, ಒಂದೇ ಒಂದು ಚಾರ್ಜ್ ಇದ್ದಾಗ ನಾವು ಯಾವ ತರ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನ ನೋಡೋಣ ರೀ. ಫಾರ್ ಅ ಚಾರ್ಜ್ ಸಿಂಪಲ್ ಆಗಿ ನಾನು ಹೇಳ್ತೀನಿ, ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಚಾರ್ಜ್ ಇಂಟು ಪೊಟೆನ್ಷಿಯಲ್. ಓಕೆ, ಏನಕ್ಕೆ ವರ್ಕ್ ಮಾಡಬೇಕು? ವೈ ದ ವರ್ಕ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಡನ್? That work has to be done in bringing the charge from infinity. ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ನ ಇನ್ಫಿನಿಟಿ ಇಂದ ಆ ಪಾಯಿಂಟ್ ಗೆ ನಾನು ತರಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಲೆಟ್ us assume that the potential at this point is V. ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ V ಇದೆ. ನೀವು ಕೇಳಬಹುದು, ಸರ್ ಚಾರ್ಜ್ ಇಲ್ಲ, V ಎಲ್ಲಿಂದ ಇರುತ್ತೆ ನಿಮಗೆ? There is no charge, but why there is a potential difference? ಅಲ್ವಾ? See, I am speaking about it is presence in terms of a external field. Andre already there is a field there. Idru sutta yavude ಒಂದು ಪಾಯಿಂಟ್ ಸುತ್ತ ನಮಗೆ ಫೀಲ್ಡ್ ಇದೆ. ಓಕೆ, ಫೀಲ್ಡ್ ಇರೋದ್ರಿಂದ ಅಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ. There is a potential. Okay, so according to the definition, the potential is the work done in moving or bringing unit positive charge from infinity to the point against the electrostatic field. ಈ ಫೀಲ್ಡ್ ಗೆ ಅಪೋಸಿಟ್ ಆಗಿ ನಾವು ಆ ಚಾರ್ಜ್ ನ ತರಬೇಕು. ಓಕೆ, ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್, ಅದನ್ನ ಏನಂತ ಕರೀತೀವಿ? ವರ್ಕ್ ಡನ್. ಓಕೆ, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ವರ್ಕ್ ಡನ್. Okay, work done at that point, you know that work done is equals to some charge into potential. Okay, some charge into potential. This work done, if I can say that Q into potential is V, this is work done. Now this work done is stored as potential energy. ವರ್ಕ್ ಡನ್ ಏನಾಗಿರುತ್ತೆ? ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಗಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. Therefore Q into V, this is potential energy of a single charge. Okay, ಒಂದು ಚಾರ್ಜ್ ಇಂದು ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಎಷ್ಟಿರುತ್ತೆ ರೀ? This is U is equals to Q Q into V. Okay, based on this, I am going to define one concept that is called electron volt. Okay, electron volt another define madana. You kelirbodhu, it is EV. Electron volt is EV. Okay, electron volt na EV antanu kariತೀವಿ. What is this electron volt? It is to define, this is energy gained by an electron. Energy gained by an electron when it is accelerated, through a potential of 1 volt, that is called electron volt. Okay, you know that it is the energy gainer. That energy or the work done is equals to, it is at again charge into at again potential. Okay, ಇಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಜನರಲ್ ಚಾರ್ಜ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದೆ, ಅಥವಾ ನಾನು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಹಿಯರ್ ಇಲ್ಲಿ ಯಾವ ಚಾರ್ಜ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ? ಐ ಆಮ್ ಸ್ಪೀಕಿಂಗ್ ಅಬೌಟ್ ಎಲೆಕ್ಟ್ರಾನ್. ಇಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇರೋ ಚಾರ್ಜ್ ಯಾವುದು? ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಚಾರ್ಜ್. ಓಕೆ, ದಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರೆಪ್ರೆಸೆಂಟ್ ಇಟ್ ಬೈ E. ಅದನ್ನ E ಅಂತ ಬರೀತೀನಿ. ದಟ್ ಇಟ್ ಈಸ್ V. ಓಕೆ, ಸಿ ದ ಚಾರ್ಜ್ ಇಸ್ 1.6 into 10 to the power of minus 19. Okay, this is 1 joule in terms of energy into potential is volt. Therefore, I can write 1 joule is equals to this 1 electron volt is equals to 1.6 into 10 to the power of minus 19 joules. Energy is in joules, right? That is electron, right? 1.6 into 10 to minus 19 coulomb into potential difference is 1 volt. Therefore, 1 electron volt is equals to 1.6 into 10 raised to minus 19 joules. Then electron volt, I can write this is unit of energy. Idana navenanta baritiviri, unit of energy. To define this, electron volt is energy gained by an electron when it is accelerated through a potential of 1 volt. ಯಾವಾಗ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ 1 ವೋಲ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಒಳಗಡೆ ನಾವು ಆಕ್ಸಲರೇಟ್ ಮಾಡಿದಾಗ ಏನು ನಮಗೆ ಎನರ್ಜಿ ಬರುತ್ತಲ್ಲ, ಆ ಎನರ್ಜಿ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ಇಕ್ವಿವ್ಯಾಲೆಂಟ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, 1 electron volt is 1.6 into 10 raised to minus 19 joules. This is the conversion factor. Okay, it can convert this electron volts to joules and joules to electron volt. Joule ಇಂದ electron volt ಗೆ ಮತ್ತು electron volt ಇಂದ joules ಗೆ ಕನ್ವರ್ಷನ್ ಮಾಡಬಹುದು. Okay, yes. Now next, potential energy of system of 2 charges. Okay, potential energy of system of 2 charges. Okay, fine, we have the 2 charges, system of 2 charges here. Okay, potential energy of system of 2 charges. Read, this is in presence of electric field. You have to note this. Heading ಗೆ ಬರೆದಿರ್ತೀನಿ ನಾನಲ್ಲಿ, in presence of electric field. Okay, ಎರಡು ಆಪ್ಷನ್ಸ್ ಇದ್ವು ಅಲ್ಲಿ ನಿಮಗೆ, ಹೌದಾ? in absence of electric field ಅದಂತೂ ಡಿರೈವ್ ಮಾಡಿದ್ದೀನಿ. here in presence of electric field ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ನಿಮಗೆ external electric field. Okay, see here, let us assume that A and B are the 2 points where V1 and V2 be the potential, then A and B are separated by the distance R. ಓಕೆ, ಇಲ್ಲಿ ಏನು ಬರೀತೀವಿ ನಾವು? V1 and V2 ಪ್ರೆಸೆನ್ಸ್ ಯಾಕಿರುತ್ತೆ? V1 and V2 are present because there is an external electric field. ಇಲ್ಲೇನಿದೆ? External electric field present ಇದೆ. Okay, yes, let V1 and V2 be the potential at A and B. Okay, let V1 and V2 be the potential at A and B. Then V1 is the potential at A and V2 is the potential at B. Okay, let they are separated by the distance R. Okay, ಅವು ಎಷ್ಟು ಸಪರೇಷನ್ ಇರುತ್ತೆ? R ಸಪರೇಷನ್ ಅಷ್ಟು ಇರುತ್ತೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇವಾಗ ಅಸೆಂಬ್ಲಿ ಆಫ್ ಟೂ ಚಾರ್ಜಸ್. ಎರಡು ಚಾರ್ಜಸ್ ಅಲ್ವಾ? ಎಲ್ಲಿಂದ ತರಬೇಕು? ಇಲ್ಲಿ Q1 then Q2. ಬೋತ್ ಆರ್ ಅಟ್ ಇನ್ಫಿನಿಟಿ. ಎರಡು ಹೇಗಿದಾವೆ? ಇನ್ಫಿನಿಟಿಯಲ್ಲಿ ಇದಾವೆ. ಓಕೆ, ಫಸ್ಟ್ ಈಗ Q1 ಅನ್ನ ತಗೊಂಡ್ಬರ್ಬೇಕು. Q1 ಅನ್ನ ತಗೊಂಡ್ಬಂದು ಹೇಗೆ ಪ್ಲೇಸ್ ಮಾಡಬೇಕು? ಹಾಗಾದ್ರೆ ಎ ಒಳಗಡೆ ಇರ್ತಕ್ಕಂಥ ಪೊಟೆನ್ಷಿಯಲ್ ಆ Q1 ಬರೋದಕ್ಕೆ ಅಪೋಸ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಎಸ್. Now what I can say, right, the work done in moving charge Q1 from infinity to point A is, okay, Q1 ಅನ್ನ ಇನ್ಫಿನಿಟಿ ಇಂದ ತರಬೇಕು. ಎಲ್ಲಿಗೆ ತರಬೇಕು? ಟು ದ ಪಾಯಿಂಟ್ A where the potential is V1. Okay, so I am going to call that as W1. You know that work done is equals to charge Q1 into potential at A is V1. Okay, therefore W1 is equals to Q1 V1. Call this equation 1. ಅದನ್ನ equation 1 ಅಂತ ಕರೀತೀವಿ. Now I need to bring the charge Q2 from infinity to the point B. ಈಗ ಪಾಯಿಂಟ್ B ಗೆ ತರಬೇಕು. See, ಪಾಯಿಂಟ್ B ಗೆ ಚಾರ್ಜ್ ನ ತರಬೇಕಾದ್ರೆ ಇಲ್ಲಿ ಎರಡೆರಡು ಫೋರ್ಸಸ್ ಅಪೋಸ್ ಮಾಡುತ್ತೆ. ಒಂದು V2 ನಿಂದ ಇರ್ತಕ್ಕಂಥ ಅಪೋಸಿಷನ್. ಇನ್ನೊಂದೇನಿರುತ್ತೆ? ಅಟ್ ಪಾಯಿಂಟ್ B there is a potential of Q1. ಆಲ್ರೆಡಿ ಪಾಯಿಂಟ್ B ದಾಗ V2 ಐತಿ. V2 is going to oppose the Q2. Next, at point B there is a potential of V1. I mean there is a potential of Q1. Already Q1 ಬಂದು ಕೂತ್ಕೊಂಡೈತೆ. Okay, Q1 is having a place at A. Therefore, because of Q1 there is a potential at B. ಆ ಪಾಯಿಂಟ್ ಒಳಗಡೆ ಪೊಟೆನ್ಷಿಯಲ್ ಇರುತ್ತೆ. ಆ ಪೊಟೆನ್ಷಿಯಲ್ ಎರಡೆರಡು ಪೊಟೆನ್ಷಿಯಲ್ ಇರುತ್ತೆ. One potential is because of external electric field V2. Another potential is because of charge Q1. ಹಾಗಾದ್ರೆ ಈ Q2 ನ ತರಬೇಕಾದ್ರೆ ಎರಡೆರಡು ವರ್ಕ್ ಡನ್ ಮಾಡಬೇಕು. ಓಕೆ, ಎಸ್. The work done in moving a charge Q2 from infinity to point A against external electric field ಒಂದು ಕೆಲಸ ಮಾಡಬೇಕು and against the potential of Q1. Okay, two work has to be done. ಎರಡೆರಡು ಕೆಲಸನ ನಾವಲ್ಲಿ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಎಸ್. ಈಗ ಎಷ್ಟು ಕೆಲಸ ಇರುತ್ತೆ? ನಾವು ಸಿ in bringing charge Q2 from infinity to point B, work has to be done against two fields. Work has to be done against the two fields. ಎರಡು ಫೀಲ್ಡ್ಗೆ ಅಪೋಸಿಟ್ ಆಗಿ ವರ್ಕ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಅದು ಯಾವುದು? ಓಕೆ, ಫಸ್ಟ್ ದಟ್ ಈಸ್ ಅಥವಾ ಏನು ಅದೇನಾಗುತ್ತೆ ಅಂತ. ಫಸ್ಟ್ the work done against external field ಇಂದ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತೆ. as usual you know that in bringing a charge q1 ಚಾರ್ಜ್ ಅನ್ನು ತರಬೇಕಾದ್ರೆ ಏನು ವರ್ಕ್ ಡನ್ ಆಗಿರುತ್ತೋ ಅಷ್ಟೇ ವರ್ಕ್ ಡನ್ ಇರುತ್ತೆ. therefore it is q2 into v2. call this equation 2. okay, now the work done against the field of q1. okay, q1 ಇಂದ ಫೀಲ್ಡ್ ಇರುತ್ತೆ ಅಥವಾ q1 ಇಂದ ಪೊಟೆನ್ಷಿಯಲ್ ಇರುತ್ತೆ. ಅದು ಏನು ವರ್ಕ್ ಇರುತ್ತೆ? that I am going to call it as w3. w3 is equals to charge q2 into potential at point B due to q1. as I told you already, work done is equals to charge into potential. One is at point A, there are two potential, already existing potential A. okay, at point B there is potential V2 plus the effect of q1 at B. okay, effect of q1 at B andre potential of q1 at B. okay, therefore work done potential at B due to q1. okay, now w3 is equals to q3 into potential is 4 pi epsilon naught into it's a potential of q1 at a distance r. okay, therefore w3 is equals to 1/4 pi epsilon naught q1 q3 divided by r. call this equation 3. okay, now total work done in making assembly of two chargers is, that is w is equals to w1 plus w2 plus w3. okay, first charge na ತರಬೇಕಾದ್ರೆ ಎಷ್ಟು ಕೆಲಸ, ಸೆಕೆಂಡ್ ಚಾರ್ಜ್ na ತರಬೇಕಾದ್ರೆ ಎಷ್ಟು ಕೆಲಸ. that is equals to q1 v1 plus q2 v2 plus 1/4 pi epsilon naught into q1 q3 divided by r. okay, therefore this is the total work done. as you know, this work done is stored as potential energy. ಅವರಿಗೆ ಏನಾಗುತ್ತೆ, potential energy ಆಗಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. therefore u is equals to q1 v1 plus q2 v2 plus 1/4 pi epsilon naught into q1, sorry the q2, this is q2. okay, this is also q2. yes, this is q1 q2 divided by r. okay, ಅಲ್ಲಿ q3 third charge ಬರ್ತಿದ್ದೇನೆ ನಾನು. it is charge q2 ಮಿಸ್ ಆಗಿ q3 ಮಾಡಿದ್ದೆ. Okay, make it q2 q1 q2 by r. This is the total energy of the system of chargers in presence of external electric field. ಅದೆಲ್ಲಿರುತ್ತೆ ಅಂತಂದ್ರೆ external electric field presence ಇರುತ್ತೆ. Okay, I hope you understood that. Okay, next ಇವಾಗ ಏನು ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಈಗ potential energy of single charge ಮಾಡಿದ್ವಿ, potential energy of double charge, system of two charges ಮಾಡಿದ್ವಿ. Next what you need to do is potential energy of dipole na find out ಮಾಡಬೇಕು. Okay, yes, now potential energy of dipole. Okay, torque acting on a dipole na now find out ಮಾಡಬೇಕು. ಹೌದಾ? Torque tau is equals to PE sin theta. I hope you all remember that. Torque acting on a dipole in an external electric field is equals to torque tau is PE sin theta. Okay, ಹಾಗಾದ್ರೆ ಅಲ್ಲಿ if you rotate that dipole through some distance, ಆ dipole ಅನ್ನು ಸ್ವಲ್ಪ ಡಿಸ್ಟೆನ್ಸ್ ಇಂದ ರೊಟೇಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಓಕೆ, ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತೆ? ವರ್ಕ್ ಡನ್ ಇಸ್ ಫೋರ್ಸ್ ಇಂಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ಹಿಯರ್ ಟಾರ್ಕ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಓಕೆ ಫೋರ್ಸ್ ಇಂಟು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್. ಇಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಏನಾಗಿರುತ್ತೆ ಅಂತಂದ್ರೆ ದಟ್ ವರ್ಕ್ ಡನ್ ಇನ್ ರೊಟೇಷನಲ್ ಮೋಷನ್ ಈಸ್ ಟಾರ್ಕ್ ಇಂಟು ದಿಸ್ ಆಂಗುಲರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ಅಲ್ಲಿ work done is equals to force into displacement. Here torque into angular displacement. Okay, now potential energy of dipole in an external electric field. Okay, potential energy of dipole in an external electric field. Okay, ನಿಮ್ಗಂತೂ ಇದು ಗೊತ್ತಿದೆ ಹೇಳಿ. Already we know this. How much the torque is acting on a dipole if you consider. ಹೌದಾ? It experiences a force. If you consider this as minus q and this as plus q, F is equals to QE in the direction of force. F is equals to minus QE opposite to the direction of the force. Okay, makes an angle theta. So it experiences a torque. Alva? Okay, see here, you know that. Consider a dipole in an external electric field by making an angle theta with external electric field. Okay, now you know this. Torque acting on the dipole. Torque acting on the dipole. Torque tau is equals to PE sin theta. You know that where P is equals to Q into 2A is called as dipole moment. Okay, ಇದು dipole moment ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ. Tau is equals to PE sin theta. Now see here, this is the direction of external field. So assume that this is a dipole. First, dipole makes an angle theta. This dipole ಏನು ಮಾಡುತ್ತೆ? Angle theta na formation ಮಾಡುತ್ತೆ with the electric field. Here there is plus q and here there is minus q. So when you rotate through dipole, ಈ dipole ಅನ್ನ some distance, ಇದು extra distance d theta move ಮಾಡಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Basically dipole is in this position by making an angle theta. See here. Okay, it makes an angle theta with the dipole. Now, if you want to tilt that dipole, a dipole na rotate ಮಾಡ್ತಾ ಇದ್ದೀರಾ. If you want to rotate this dipole, so angle changes. Suppose if the angle change even by small angle d theta, ಒಂಚೂರೇ change ಆಯ್ತು d theta ಅಂತ assume ಮಾಡ್ಕೊಳ್ಳಿ. If it changes by d theta, okay, now there is a work done on that. Okay, ಇಲ್ಲಿ ನೋಡಿ straight line motion ಒಳಗಡೆ work is equals to force into displacement. E dw is equals to f into ds ಕರೆಯುತ್ತೀವಿ. Here in this case dw is equals to tau into d theta ಅಂದ್ರೆ torque into angular displacement. Work done is equals to force into displacement. Here work done is equals to torque into angular displacement. Okay, torque into angular displacement. ಹಾಗಾದ್ರೆ ಈ ಡೈಪೋಲ್ ಅನ್ನು ರೊಟೇಟ್ ಮಾಡೋದಕ್ಕೆ ನೀವು ವರ್ಕ್ ಡನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ನಾವು if the dipole is rotated through small angle d theta, now the work done in rotating dipole through small angular displacement d theta is ಏನು work done ಇರುತ್ತೆ. That I am going to call it as dw, that is tau into d theta. Okay, tau into d theta. Now as you know dw is equals to tau is p is sine theta into d theta. Okay, you know that the tau is equals to p sine theta into d theta. Now suppose if you want to tilt this dipole from small angle theta to bigger angle like this. Okay, first angle churi ivaga angle bar. Okay, now the total work done in rotating dipole from theta 1 to theta, ಯಾವುದೇ ಒಂದು ವ್ಯಾಲ್ಯೂ theta 1 ಇಂದ theta 2 ಗೆ ಇನಿಷಿಯಲಿ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ರೊಟೇಟ್ ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ ಅಲ್ವಾ. ಎಸ್, ನೌ you have to integrate this. dw is equals to integration of pe sin theta d theta, limits running from theta 1 to theta. This becomes what done? It is pe integration theta 1 to theta 2 sin theta d theta. Okay, differentiation of sin theta is cos theta and integration of sin theta is minus cos theta. Okay, it is minus cos theta. That is equals to pe into minus cos theta running from theta 1 to theta 2. Therefore, work done is equals to minus pe cos of theta 2 minus cos of theta 1. This is the work done. Okay, idu work done. Okay, now suppose if theta 1 is equals to 90 degree initially, andre if that dipole is perpendicular to the electric field, idara tilt ಆಗಿರೋದು ಅಲ್ಲಿ ಡೈಪೋಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇದ್ದಾಗ ಓಕೆ ಇನಿಷಿಯಲಿ if theta 1 is equals to 90 degree and you are rotated through some angle theta. Now work done is equals to minus PE into cos theta minus cos 90. You know that theta 2 is theta. Theta 2 value ಏನು theta. Theta value ಏನು 90. Cos 90 is 0. Therefore work done is equals to minus PE cos theta. ಹಾಗಾದ್ರೆ work done in rotating the dipole is going to be minus PE cos theta. Now this work done is stored as potential energy. Therefore U is equals to minus PE cos theta. This is the formula for the potential energy of a dipole in an external electric field. Okay, I hope you understand this. Okay, see here, simple. ಇಲ್ಲಿ ತನಕ ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿರುತ್ತೀರಿ ಥೀಟಾ is equals to p sin theta ಅಂತ. ಈಗ ಈ ಡೈಪೋಲ್ ಅನ್ನ ರೊಟೇಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? When you rotate this dipole, okay, so it is going to make some angle d theta. Okay, that is p sin theta into d theta. The work done is equals to work done ಏನಿರುತ್ತೆ? Work done is going to be torque into angular displacement. ಹೌದಾ? So torque is p sin theta into d theta ಅಲ್ವಾ? ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸಿಂಪಲ್ ಇದೆ ಇಲ್ಲಿ ಸ್ಮಾಲ್ ಡಿಸ್ಟೆನ್ಸ್. ನಾವು ಯಾರ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ಥೀಟಾ 1 to ಥೀಟಾ 2 ಪೂರಾ ಥೀಟಾ 1 ಇಂದ ಥೀಟಾ 2 ಗೆ ರೊಟೇಟ್ ಮಾಡಿದ. That is p is equals to integration of theta 1 to theta 2 sin theta. Integration of sin theta is minus cos theta with the limits theta 1 theta 2. It is cos theta 2 minus cos theta 1. Therefore work done is equals to minus PE cos theta 2 minus cos theta 1. Initially if it is 90 degree, in other words initially if the dipole is perpendicular to the electric field, dipole electric field ಗೆ perpendicular ಆಗಿದ್ದಾಗ, okay, now we have this cos 90 ಬರುತ್ತೆ, cos 90 is 0, W is equal to minus P cos theta. This work done is stored as potential energy. ಇದೇ work done potential energy ಆಗಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. Okay, now we have some special cases. ಕೆಲವೊಂದು ಸ್ಪೆಷಲ್ ಕೇಸಸ್ ಇದಾವೆ ನೋಡಿ ಇಲ್ಲಿ. You know that U is equals to minus PE cos theta. This is the formula. Suppose if the value of theta is going to be 0, then you know that cos 0 is equals to 1. The value of cos 0 is equals to 1. Now U is equals to minus PE. U ಏನಾಗಿರುತ್ತೆ? Minus PE means it possesses the minimum energy. Dipole possesses the minimum energy. The minimum energy possession of a dipole, minimum energy possession of the dipole is called a stable equilibrium. ಅದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ? Stable equilibrium. When the energy is minimum, that is called the stable equilibrium position. Means if the dipole is along the direction of the electric field, if the dipole is along the direction of electric field, the energy is minimum. Second thing, if theta is equals to 90 degree, cos 90 is going to be 0, then energy is going to be 0. Our energy is 0 irutte. Means dipole do not possess any energy when it is perpendicular to the electric field. Electric field ಗೆ perpendicular ಆಗಿದ್ದಾಗ ಯಾವುದೇ ರೀತಿಯಾಗಿರತಕ್ಕಂತ ಎನರ್ಜಿನ ಪೊಸೆಸ್ ಮಾಡೋದಿಲ್ಲ. Okay, next, the third condition, if theta is equals to 180 degree, we have cos 180 is equals to minus 1. Cos 180 is minus 1. Therefore, u is equals to minus p into cos 180. Yes, minus p into minus 1, u is equals to pe. In this position, the dipole is having maximum energy. Dipole ge ಏನು ಎನರ್ಜಿ ಇರುತ್ತೆ ರೀ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಎನರ್ಜಿ ಇರುತ್ತೆ. And this position is called as unstable equilibrium. Okay, ಈ ಪೊಸಿಷನ್ ಅನ್ನ ನಾವು ಅನ್ಸ್ಟೇಬಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂತ ಕರೀತೀವಿ. ಓಕೆ, ಅರ್ಥ ಆಗ್ತಿದೆನಾ? See, in this we have the three conditions. First is, what is the potential energy? Potential energy ಎಷ್ಟು ಅನ್ನೋದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಸಿಕ್ತು ಅಲ್ಲಿ? in general ಆಗಿ u is equals to minus p cos theta 2 minus cos theta 1 ಅಲ್ವಾ? ಈ ಪೊಸಿಷನ್ ಇಂದ initially when you assume that the dipole is perpendicular to electric field, dipole electric field ಗೆ perpendicular ಆಗಿದೆ ಅನ್ನೋದನ್ನ ಅಸ್ಯೂಮ್ ಮಾಡಿದ್ರೆ ಆವಾಗ theta 90 degree ಬರುತ್ತೆ, theta 2 theta ಬರುತ್ತೆ. Substitute ಮಾಡಿದ್ರೆ we will get work done is equals to minus p cos theta. ಹೌದಾ? This is the work done. From this work done, that the same energy is stored as electrostatic potential energy. ಅದೇ ಎನರ್ಜಿ potential energy ಆಗಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. Okay, then potential energy is different at different positions. Okay, ಬೇರೆ ಬೇರೆ ಪೊಸಿಷನ್ಸ್ ಒಳಗಡೆ, in other words ಬೇರೆ ಬೇರೆ ಆಂಗಲ್ಸ್ ಒಳಗಡೆ potential energy ಬೇರೆ ಬೇರೆ ಆಗಿರುತ್ತೆ. Okay, so when the angle between them is 0 angle ಇದ್ದಾಗ, that is the dipole is along the direction of external field. ಇದು field ಆ? Okay, dipole ಹಿಂಗೆ ಇದೆ, means dipole moment minus q plus q ಹಿಂಗಿತ್ತಂದಾಗ electric field ಇರುತ್ತೆ 0 angle parallel ಇರುತ್ತೆ. ಹೌದಾ? ಅವಾಗ it possesses the minimum energy. ಅವಾಗ ಏನಿರುತ್ತೆ ಅಲ್ಲಿ? ಎನರ್ಜಿ ಮಿನಿಮಮ್ ಇರುತ್ತೆ. when it possesses the minimum energy, that position is called as stable equilibrium. ಆ ಪೊಸಿಷನ್ ಅನ್ನು ನಾವು ಸ್ಟೇಬಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಪೊಸಿಷನ್ ಅಂತ ಕರೀತೀವಿ. then when it is perpendicular ಆಗಿದ್ದಾಗ 90 ಡಿಗ್ರಿ ಇದ್ದಾಗ cos 90 is going to be 0. ಹಾಗಾಗಿ ಎನರ್ಜಿ ಕೂಡ 0 ಆಗುತ್ತೆ. 0 ಮಿನಿಮಮ್ ಅಲ್ಲ, ನೆಗೆಟಿವ್ ಇದೆ, ಅದು ಎನರ್ಜಿ ಮಿನಿಮಮ್. ಓಕೆ, yes, next, if theta is 180 degree ಅಂದ್ರೆ if the dipole is opposite to electric field ಹಿಂಗಿದೆ ಅಂದ್ರೆ dipole ಹಿಂಗಿದ್ದಾಗ, if both are opposite, theta is going to be 180. cos 100 is minus 1, it is minus into minus plus p. ಅಂದ್ರೆ in this case the potential energy is maximum. ಈ ಪೊಸಿಷನ್ ನಲ್ಲಿ potential energy maximum ಇರುತ್ತೆ. Okay, the maximum potential energy position is called as unstable equilibrium. ಅದನ್ನ unstable equilibrium ಅಂತ ಕರೀತೀವಿ. Okay, fine then. I hope you understood about what is stable equilibrium, what is unstable equilibrium, and what is work done and energy stored in the dipole. Okay, I hope you understood this. I'll stop here and I'll continue in the next class. Thank you very much.